Verify cos square x minus tan square x over sin square x equals cot square x minus secant square x. Now, it's better to convert everything to sines and cosines, which means if I want to start on the left side and I want to arrive on the right side, let's try to see if we can do that. So, copy the left side is this fraction where the numerator is cos square x minus tan square x over sin square x. So, we want to convert this tan to sine over cosine. So, your numerator is going to be a little bit complicated now. It's going to have cos square x as one term and then minus there will be a fraction which is sine square x over cos square x. And then your denominator is just sine square x. So notice the numerator has become a little bit complicated. So we have to combine these two fractions. Now cos square x is not a fraction, but we can always convert it to a fraction by thinking this as over 1. And how do you combine two fractions? Well, adding or subtracting fractions is rather fast if you do it this way. Your numerator is going to be the cross product. So if it is a over b plus c over d, you take AD plus BC for your numerator, which is the cross product, and your denominator is just BD. But if it's minus, you write AD minus BC for the numerator. Denominator is still the same. It's BD, product of the denominators. So let's go ahead and work on the numerator. Now the denominator is just sine square x. And the numerator is subtraction of those fractions. So I'm going to take cos square x times cos square x, which is cos to the 4x, minus sine square x times 1, which is minus sine square x, divided by cos square x. So notice I have to divide this fraction by sine square x. Now that is same as copying the numerator, which is cos to the 4x minus sine square x over cos square x. And if you want to divide by sine square x, that's same as multiplying by its reciprocal, which is times 1 over sine square x. And now what do we have? So we have this. To multiply two fractions, you simply multiply the numerators. So I'm going to multiply this cos to the 4 minus sine square with 1. Now, anytime I multiply by 1, nothing changes. So I'm going to have simply cos to the 4x minus sine square x in my numerator. And the denominator is cos square x sine square x. All right, let's keep going. Now, if you have just a monomial in the denominator, you can always separate this into two fractions. So I can divide just this first term, which is cos to the 4x, by the denominator, which is cos square x sine square x, and minus sine square x over cos square x sine square x. I could do that because there was only one term in the denominator. Now notice, what I have here in my first fraction is 4 copies of cos in the numerator and 2 copies of cos in the denominator, which means I can simplify this. So the 2 of them will cancel with the denominator. So I have 2 left over. And if you notice here, there's a sine square x sine square x. I can cancel that, but I have to write 1 here because sine square x goes into sine square x 1 times. So now what do I have? I have cos square x over sine square x minus 1 over cos square x. So what's that going to be? Well, cos over sine is cot. So this is going to be cot square x. And what is 1 over cos square x? Cos is the reciprocal of secant, or secant and cosine are reciprocals of each other. So look, we arrived at cos square x minus secant square x, which is the same as the right side. So we started on the left and arrived at the right. So we are done.